It is a great pleasure for me to introduce our second speaker for tonight, Professor Anne Williamson. She is from UNSW, a professor in aviation safety, and she is also the director of Transport and Road Safety Research Institute. She's a fellow of the Royal Society of New South Wales and the Australian College of Road Safety. Despite all that, I don't know. In conjunction with that, she has a PhD in psychology, so the way she's coming at all these topics is maybe not initially what you expected. So her research focuses on human factors, the areas of transportation and workplace safety, especially the role of error and the effects of fatigue on performance. Without further ado, the floor is yours.
Thank you very much. Okay, thank you very much. Okay, I'm sorry to the people on either side. I'm not going to stroll up and down because I'm stuck near the microphone, so I do apologise. I'll try and look at least sideways occasionally. Thank you very much for the invitation to speak. I'm interested that you might be interested in this stuff, and anyway, we'll get to the end and see whether that's true or not. Look, I'm particularly interested in putting an argument to people about this whole issue of automation. What I'm going to say is really relevant not just to road safety, but given that road and travelling on the roads are probably one of the most dangerous and risky things that any of us do, it probably matters most there. But the sort of issues that I'm raising are true for all sorts of things that we do in our daily lives, and increasingly that's becoming the case. And the whole issue comes down to a large amount of will automation benefit road safety? Will automation benefit insert whatever it is that the outcome that you're interested in? Talking about road safety though, it really does depend on who you ask. Certainly if we're focusing on the vehicle, which is very much the engineering and the technology end of things, then we'll get one answer. If you focus on the human use of the vehicle, people like me, human factors and ergonomics view, you're going to get a slightly different answer. Now, it's obvious, Fabian's already told you where I come from, so I am going to be talking a bit about the human side of the automation and the use of vehicles and use of new technology. And it's not really a one side or the other. What I'm arguing is that we need to bring them together, and there's a piece missing in what we're doing at the moment. There's a nice little picture of the Google car there. Everyone's seen the Google car and so on, so this is no surprise. And certainly there's an awful lot of argument about the fact that we are going to be seeing benefits of automation on our roads, and they're going to be wonderful. The kinds of benefits that we're seeing, the kind of argument that's put certainly in road safety is that there's going to be a 90 to 95% reduction in crashes because most 90 to 95% of crashes are caused by driver error. You take the driver out of the system, you don't have any more errors and you don't have any more crashes. It's simple. I wish it was. And this sort of thing is reported by highly credible organisations. This is I've just cut out from the UK's Institute of Mechanical Engineers. A lot of people who really do know their stuff, and it's the professional body. The same thing is happening in Australia and the US and around the world. Certainly Austroads, who are the peak body for road safety in Australia, say this. So does the National Road Safety Forum, which is another discussion group around what's happening in road safety. They're all arguing it. Aside from that, there are also other benefits of automation. Certainly the work that's been done that's attempted to look at the cost savings, they're estimating 2,000 to 4,000 US per vehicle, and this is due to crash and travel time reductions, fuel efficiencies, parking benefits and so on. And you've probably read some of the articles in the media about all sorts of things going to happen when we've got autonomous vehicles. And the other thing that's being said a lot at the moment is that we're seeing this as happening in the really near future. 5 years, 10 years, I mean, certainly it's very much near horizon that we're being promised that these things are going to happen. And in fact, the testimony to that, as is often argued, is that it's already on our roads. They're already here. The Google car is here. The Tesla is here. Volvo's got various new products out, and in fact a lot of the technologies in your vehicles already are steps towards automation. And in fact, one of the things that is most recognised, there are about 3 or so of this kind of thing. This is a framework that talks about levels of driving automation. And there's a lot in this, but I just want to highlight a couple of important things. First of all, that on the one hand, level 0 is no automation. Level 4 here, a five-level taxonomy, is full self-driving autonomous vehicles. This is the source for this is the NHTSA, which is the National Highway Safety and Transport Safety Organisation Authority, I think, in the US. They do an awful lot of work in this area, but the Society of Automotive Engineers has something similar. The German Road Safety Institute has something similar to this as well. And what you can see is from 0 automation right through to full automation, there are stages. We're probably between 1 and 2 at the moment, where 1 is you've got function-specific automation of various sorts, like stability control, ABS brakes and so on. You actually have technology in your vehicles that actually cover certain functions of the vehicle. But also we're seeing more and more level 2, where you're getting combined function automation, where you might have adaptive cruise control that's working in coordination with say, lane tracking. And there are certain vehicles in the market that are starting to do that. So we are somewhere between 1 and 2. The big leap is the next one, in this taxonomy anyway, where we're getting limited self-driving automation. Volvo, Tesla certainly has a vehicle out at the moment that has autopilot that's actually on our roads, and you see increasing numbers of them. Volvo's got one as well, Mercedes, all of the big companies have got them. One of the issues here, there are a number of issues, but the leap between level 2 and level 3 is quite a big one, because you start to have the issue of, well, who's driving? In New Zealand, wouldn't matter, because there's no specification of who's driving. There's nothing in road law that says the driver has to drive. Here in Australia, that's not true. We will have to change the law or do something different to actually make that leap in any significant sense. And certainly the move to full self-driving automation is a really big one. So increasingly what we're seeing is the big leaps from, a little bit to more to, well, who's driving now, me or the vehicle, right through to the vehicle doing the driving. And the other thing, as the human factors person, I want you to note, as we move across from 0 to 4, the role of the human is getting less and less and less. The task for the driver is starting to become less and less. And here is one of the problems. We'll talk about that in a minute. The range of automotive and driver assist technologies, ADAS systems they're often called, that are currently in use, you know these. There are a whole lot that are seamless to the driver, like automated braking systems, electronic stability control and adaptive cruise control. Well, the last one isn't quite so seamless, but the first two, many people will have them in their vehicle and don't even know it, and possibly don't use it very well, but they may not even know they've got it. That seems to be the case. But then you also get driver interactive ones, lane departure warnings, you get forward and reversing warnings, we've all got those, cruise control, just ordinary cruise control, and navigation systems. They're all there, and they're all things, they're all technology that can help, ostensibly, help assist driving. the differences between my two categories there is that on the seamless for the driver, the idea is that the technology works behind the scenes. The driver actually isn't aware of the technology or is largely not aware, and they don't require the driver to do anything. You'll see when I talk a little bit more, that's not necessarily true. And certainly, I've given this talk a couple of times, and people often afterwards come and tell me about the time their electronic stability control did this and made itself very obvious to the driver when they didn't expect it. And this can be one of the problems of automation and the way we're moving towards automation in vehicles. The difference with driver interactive types like lane departure warnings and so forth, they're all focusing on technology that actually warns the driver and requires a response from the driver. The driver actually has to do something as a result of the warning. So it requires rapid reactions, you know, the lane departure warning, oops, I better move. Now, some vehicles will actually do that for you, but in many vehicles at the moment, the assistive technology is just a warning. It's more things going off. The same thing with reversing technologies and so forth that tell you you're going backwards, but when you do know it, actually. We have well-recognised issues already between in the human interface into automation. Whilst the automation itself in our vehicles is relatively new, we've known for more than 20 years that there are problems in moving to automation. I've got a couple of golden oldies, if you like, famous papers, famous research and commentary that have highlighted the fact that automation is not necessarily something that we should just be accepting, and that the role of the human in automation is something we need to look at more. Liz Ann Bainbridge's work in a paper in 1983, and if any of you are following this area, you've probably read it. It's a little paper. It's not especially well written, but she does say one really important thing, and that is that the more advanced a control system is, the more crucial may be the contribution of the human operator. So that as the machine is looking after itself, how it interacts with the human is something that we neglect to actually pay attention to at our peril, whether it's you, the operator, or the people that are around it. Similarly, there's a very lovely paper by Raja Parashuramon and a colleague called Humans in Automation Use, Misuse, Disuse and Abuse. Great title. But certainly this one really also is highlighting, this was written in 1997, so we're talking about, this is not new stuff, that highlighting that there are some issues here, that the interface between the human and the automation, maybe it's not as simple as we'd like it to be. I come from aviation, and as one of my modes of transport that I'm interested in, we see this in aviation, and there's a lot on this slide and I haven't got too much time, so I'll just briefly talk about the main points. Look, we know that there's increasing automation in the cockpit. Airbus, for example, has studiously worked on engineering out the pilot. As far as Airbus goes, pilots are just a damn nuisance, and really we'd be better off without them. Their aircraft will in fact fly without a pilot. Whether the passengers sitting behind actually like that or not is the reason we still have pilots, and because we've had some notable crashes where the automation itself and the technology and the interface between the cockpit flight controls and the pilots and what the pilot can know about the circumstance has actually caused crashes, and certainly made the recovery from incidents like the QF32 incident over Changi Airport, where a bolt shot out of the engine and took out half the flight controls. They had something like 132 checklists, safety checklists going off because it took out so much of the controls, and the computer, the system just couldn't cope. The trouble was that the pilots didn't have any idea about what was going on either. And this really, it was only when the pilots went back to basics, and fortunately they'd all learned how to fly straight and level when they were, young tackers, and they could actually bring that plane down. But even then, when they got on the ground, there were still issues. I mean, I'm sure you know the story. But Certainly the research in automation has led the way because it's early. It's been early. There have been pilots, you ask pilots, as some researchers have, about automation surprises in the cockpit, and you end up with a whole lot of things that tell you about how the automation has actually failed, and you know, pilots still have to manage to fly the aircraft. This is culminating now in the FAA, the US Federal Aviation Authority, did do a review of automation in flight deck, and their conclusions, it took them about 5 years to do this review, but they finally have recommended that pilot technology interfaces really need to support the pilot. The pilot is there to fly the aircraft, the pilot should be in control, the flight deck is there to make it easier for the pilot, and fundamentally, flight deck interfaces need to be intuitive to the pilot. They need to work the way the human expects them to work. And I think from aviation, we need to be learning some more. A very quick segue. This is an example of a relatively old vehicle now. This is a Honda CR-V. I'm sure if I asked for a poll, there'd be people in the room who own one. Certainly, they've had a number of recalls. One of them, the second recall, was that the collision mitigating braking system was fitted to the CR-Vs that were built and sold in Australia in 2014 and 15, had a bit of a problem in that the system could misinterpret some roadside furniture like guardrails and fences, you know, commonly found on the roads, and the vehicle would suddenly stop. Now this isn't something that the driver wants, clearly, and neither is the driver behind, and so forth. And the journalist, the motoring journalist, made the, I think, very astute statement that said, while technology such as this and other autonomous braking systems are a potential lifesaver, it needs to work flawlessly every time. Here's my other point, that isn't the case at the moment. We do know a bit about, from evaluations of driver assist technologies. We know, for example, that self-driving vehicles, like the Google car, the work that's been done is showing that they have higher numbers of crashes. Now, the authors of that study, was done in, published in 2015, make the point that, look, it's still rather low kilometrage for these vehicles, and really accidents and crashes are really rare events, so maybe they haven't been tested enough. Certainly they tend to be low severity, but that's often because these vehicles aren't going very fast, and they're often caused by the other vehicle. We could talk a lot about the implications of those findings, but certainly it raises some issues. The Insurance Institute for Highway Safety also has got some quite interesting data that shows that lane departure and warnings actually increase crashes in their insurance claims. There's a large amount of research on cruise control. I know people hate this one. People like cruise control for a whole lot of reasons, but I'm afraid the research shows that people's response time when you recover from to take control of the vehicle is significantly longer. Reaction time slows. Now, whether we think that's important or not, it's something that happens, and we need to take it into account. Certainly, there is also evidence that reliable in-vehicle warnings, that is, things like lane departure warnings and so forth, if they're reliable, actually improve performance. But when you start getting false alarms, the opposite happens. Stands to reason. I mean, why would I be paying attention to it? My reversing and forward sensors go off all the time. I stop paying attention to them, and I use my camera. I use them a bit, but you know, and that's not actually what you want. Is that assisting a driver? Maybe not. And certainly there is evidence that driving performance deteriorates with increasing automation. There have been a couple of studies. One of my big issues is that these kinds of findings are being largely ignored, and that we are looking at a sensor technology that at the moment is still inadequate. They lack reliability and they lack sophistication that's needed to really do the job properly. And furthermore, the thing that's missing in our move to automation and driver assistive technologies is we're forgetting that there's a user in the interface that needs to be taken into account. And there's a general lack of attention to the usability of vehicles, and including these driver assist technologies. Examples. there are lots and lots of examples of poor design in our vehicles. We think they're they're much better than they were in, 1908 when we had vehicles that you had to have the man out front with a white flag waving because, there were dangers. Many of our vehicles are great, there's no doubt, but there are things in our vehicles that shouldn't be there, such as parabolic mirrors, side mirrors that actually give us information. Yeah, they tell you about blind spot, but they also give you false information about how far away the car that's coming up rapidly along your side actually is. We have no idea how many crashes are caused by parabolic mirrors. No one's asked that question, but we know that this is a risk. A-pillar design in vehicles, these are prosaic kind of examples, but they are examples of the fact that we haven't got it right yet. The A-pillar in many vehicles, that is the pillar that's beside the driver's side, often has got wider because that's where the airbag is, and the engineers need they need space for that's the airbag. What it means though is that I have photographs of me standing right beside the vehicle and not being able to be seen. Now I know I'm not huge, but I'm not that tiny either, and it's very much a case that a pedestrian who's crossing can be completely obliterated by the A-pillar. How many people here have actually nearly had an accident? Okay, thank you, because of that. Certainly the sensitivity of forward warnings, they go off even when you're stationary and so on and so forth. One of the issues is that these kind of technologies that don't actually assist you can actually make it more likely that you will make an error, that you'll hit that pedestrian because you didn't see, that you'll merge when you shouldn't because you've misjudged how quickly the vehicle is coming along the side. And the issue is, if we haven't got these right, are we sure that automation is going to be any different? I just very briefly go through the usability issues that I think there are in driver assist technologies, and there's a lot more to be said, but I'll just highlight them. Certainly the driver assistive technologies, especially the autopilot type technologies, do the one thing that is really a problem for drivers, and that is they turn what is an fairly active type task, that is I'm driving and I'm interacting with the road and I have to keep watch, to something that's passive. I then, as the driver, I sit there and wait until the vehicle wants me. And that's something, humans are very bad at doing that. We're really good at engaging with the things around us when it's interesting, but once it gets a bit boring, all of us know this, we'll do other things. So, when Tesla says, oh, but you have to have your hands on the wheel all the time, when Volvo says you've got to have your hands on the wheel all the time, well, yes, but my brain can be elsewhere. I can be just checking my phone because I don't have to do anything, etc., etc. And the taxonomy I showed earlier is actually pointing that out, that we get less more passive interaction as we go further up that taxonomy. There really has been no attention at all paid to, well, what should we automate? What sort of things do drivers need help with? Certainly if we go straight to full automation, then we have no issue. The driver doesn't have to do anything. Hallelujah, I can do my emails, I can read my book and make phone calls at my delight whilst I'm driving. That would be great, but we're a long way off, and the steps in between are really of concern. The transition of control between automation and the driver, that is the interface, the actual interface. As I said, turning the task into something that's more passive is really going to be a problem. It is already a problem. And the issue then becomes, well, okay, the vehicle says it's your turn to take over. The research at the moment is suggesting you need around 8 seconds before the driver will get even anywhere near being back in the loop of what is actually going on. And the longer it's been since I haven't had to be back in the loop and driving, the worse that's going to be. Certainly there's poor design of much of the technology, and I don't know, there may be people in the room here who do design technologies. One of the things that we see all the time is that, oh well, yeah, I need to tell the driver something, so I have yet another auditory alarm going off, yet another warning. In aviation we know that doesn't work. QF32, there was a cacophony of, warnings and buzzers going off. Didn't help because they weren't distinguishable. The same thing in our vehicles. My vehicle, I've got a relatively new car, it goes off all sorts of times. I have no idea what it's telling me, so I ignore it. This is not helpful. And we unfortunately, until our sensors are 100% effective, they're not reliable and unsophisticated, they shouldn't be in vehicles. And certainly we've got more work to do. Look, there are other issues of trust and acceptance, which I won't go into because I've already had my 5 minutes and it's probably 5 minutes. But certainly, look, there is... Many of my colleagues in this area say, oh look, the issue is we've got to get people to accept new technology. Well, why would you accept something that you know is imperfect? Why would you, the assistive technologies we've got at the moment, we're already, my reversing sensors, yes, they're useful, but I don't actually trust them all the time. I do need to check. How many people here look over their shoulder when they're merging? Yep. Case rests. Legal issues, well, the issue of who's driving is one, and there's a whole bunch of things which we could spend more time talking about too. Why am I here? Talk about big data. This is an area where data and big data and data sets are absolutely available for use, and it's one of the things we need to be doing. My issue about human usability is partly resting on the fact that we haven't looked at how the human interacts. We need to be using the data sets that are available, and there are some. For example, in Europe at the moment, there's a European field operational testing network being set up. And this has been is a big data repository that all the big manufacturers are being encouraged to actually put data in. I think Mercedes are there and Daimler and a few others. And this is the data they collect when they do the testing of their new technologies, when they do their testing of the things that they've got in their vehicles. This information is being put up and will be available for those who join FOTNet, as they call it. And the possibilities here to look at how the human actually deals with the technology rather than whether or not the technology just works, which is what has typically been the case. Other types of data sets would be naturalistic driving studies. We're just about to finish one at the University of New South Wales, along with 3 other universities around Australia. This is looking at what normal drivers actually do when they're driving. We need to know this kind of information. We're about to set up a repository of information that tells us about what normal drivers actually do. When do they drive? How often they drive? How fast do they go around corners? What does normal driving feel like? If you're going to put new technologies in vehicles, this kind of information is really useful, and there's potential here for a huge amount of new stuff to be done. Just briefly, I'll get on to the final thing to say, answer my own question. Will autonomous vehicles improve road safety? Answer, I'm sure you know, it's probably not, at least not in the short term, not until we get to the end of full automation, and then we have to be sure that we've got reliable, sophisticated, well-designed technology that does actually interact with the driver in a way that's suitable for the driver, because it won't be a mind reader, you'll still have to program it, etc. But it's certainly the case that the technology we're seeing now, the ADAS technologies, the driver assist technologies, are definitely ones that actually we have huge potential to actually increase driver error, and we really do need to stop now and look very carefully about what we're prepared to accept. The blue bit down the bottom is just raising the issue of, somebody said to me a few months ago when we were talking about this stuff, well, look, maybe we're going to have a decrease in safety initially in order to get to where we want to go, because that is what happened in aviation. They crashed many more times early on. Do we have to? I don't think we do. I think we're much smarter than that. The genie is certainly out of the bottle on this one. We can't go back. And you talk to the government agencies and so forth about this whole issue, and they all throw their hands up and say, it's all too hard, don't know what to do. Certainly, I think there are some obvious things to do. We need to ensure that technology is fully tested and developed and usability tested before they're allowed on the road. And it's not just the current regime of, well, does the technology work? No, does it work with the user, with all the other things that are in the vehicle? We have to ensure that the focus of the technology development is really on the major thing. That is, it's a tool for people to use. It's not the driving task itself, it's people doing the driving task. That's where the focus needs to be. And it's the question of, well, what do we automate? What do people need assistance with, etc., etc. There is also, this is my last thing, there is a possibility of we can do something right now, and I think this is something that I would like to see happening. I'm working towards getting this happening. We have a thing called ANCAP, Australian New Car Assessment Program. There's a Euro NCAP, European New Car Assessment Program, and the US have them as well. The stars on cars, you can buy a 5-star car or 4-star or 3-star, and currently they're designed, the star system is given to vehicles based on their crash worthiness. That is, will they protect the driver if there's a crash? And it's been argued that it's a good idea, but it could take a long time for the whole vehicle fleet to change from what was originally 1 or 2 stars right to 5-star cars. My graph here, this is for data science, I've got one graph, sorry. This is showing that in fact there's been a very rapid change in terms of the stars on cars in the vehicle fleet in Australia. For those who can see, the leftmost, as you're looking at it, bar is year 2000, and you can see the yellow stars, the gold stars at the 5-star. You can see that virtually none of the fleet were 5-star then. Moving up to 2015, you can see a very large proportion of the vehicles are 5-star, and it was a very rapid uptake. We can do the same sort of thing with usability of vehicles, usability of technologies in vehicles. This is something that actually can be done. And it's certainly something that I think we, the road users, members of NRMA and so forth, should be talking to our representatives to actually start demanding that we don't have less than adequate technology in our vehicles. So, well, I think we do need to change the focus in transition towards automation. Big data is one way of doing this, but certainly it's not introducing technology because we can, and this is not just for vehicles, as I said, but certainly it matters hugely in vehicles. But we need to be asking the question of what's the best way to assist the driver and other road users, and we need very much to improve the design of the human-machine interface, and this is certainly where the data we're collecting can be used to help us do that, with the fundamental premise that vehicles are tools for people to use, so that drivers and people should be the focus, as is true for all automation. Thank you very much.
Thank you very much, Anne. Are there any questions right there?
Hi, my name is Prasad. Would like to ask, because I faced certain problem with automatic, and I'm driving Nissan Altima.
Oh.
Okay. Does it, you don't have to start with a key or something?
Yep.
Okay, when I stop the car, many times I get to switch off the engine.
Yes.
In fact, I wrote a big mail to Nissan.
Did you?
With the design.
Good for you.
Okay.
Yeah.
The thing is, do you have any kind of things, because I have a remote which should assist me.
Yep.
Suppose if I forget it.
Yes.
It was not doing so.
Yeah.
So I was issuing that, anyway, that customer service problem, she was explaining the same repeated things. She did not understand my intent of design thinking.
Right.
Okay. The second thing is, there are a lot of things happening in the telematics.
Yes.
Okay. So what do you think about that?
I think that we've got the same issues. I mean, a lot of it boils down to the reliability and accuracy of the technology and how it's implemented. So you just insert any kind of issue, but certainly, I mean, telematics certainly have communicating vehicles, connected vehicles is a big issue at the moment, and there's lots of discussion about it. The thing you don't want to happen is to have, my vehicle's connected to yours and that they're talking, and I have more buzzers going off in my vehicle telling me, there's a car coming. I'm sorry, I can see that. I mean, we're talking, I know this is silly to the extent that, I shouldn't even be discussing this, but unfortunately, based on what we have now, that's likely to be what we'll have. Yes, tell me if it's something that I can't see, then please help me, be assistive. But if it's there because it can be, and nothing else, and it isn't actually assisting making me safer. In fact, it's likely to make me more angry, and I'll make an error because I'm shouting at the technology, which has happened. This is not an advantage. But I should also, you might be interested, we're about to run a survey which we're hopefully going to advertise through the NRMA and the RACV in Victoria. We're interested in automation surprises in vehicles, in cars. So we're going to be asking people to just give us, it's a very brief survey, so I would really be interested. I can let the Data Science Sydney know the URL, and we'd love to hear about your example. Because nobody's collecting this kind of information about the failures, and we need to know about it. I mean, the fact that nothing terrible has happened is great, but we do need to know where the technology isn't doing what it needs to do, because that information needs to be fed back to the manufacturers, obviously, but also our governments, the decision makers, the people who say yes, this could be allowed on the road because it's safe or not, do need to take some responsibility on this, I think.
I lost a whole load of petrol.
Yeah, I'm sure it's scary.
Okay.
Yeah, thank you for your presentation. I think there's a lot of car manufacturers particularly who've realised they can't jump to fully automated straight away.
Yes.
And they're trying to move up the assisted path. As a cognitive scientist in my misspent youth, I think you've pointed out a big fallacy with that. My question though is, do you think that the cognitive scientists should focus on the path up? Because people like Google are intending to go straight to level 4.
Yeah.
Their intention is not to risk that cognitive lag when they switch over, and to go full autonomous, and only to come back if there's a problem. Is it in fact better to focus on ways of interacting with the human when things really go wrong, so that they can take over smoothly rather than trying to go up the assisted path?
Yeah. Look, I have taken the view that I think ideally we should go straight to fully autonomous, which will take a long time.
6 months for limited routes.
Yeah, but I mean, in Perth they have a bus that drives around a little loop, but it drives very slowly. It's got somebody sitting beside it. I mean, it's like a Ferris wheel. They're gizmos. It's not. We need to get real here, because this is going to happen to us. This is not trivial. We are having this happen, and we really want it to happen in a way that actually is beneficial to us. I mean, why else do we want it? I mean, I would love to have a car, as I said earlier, that will take me places and I don't have to think about it. I don't happen to love driving. I know there are lots of people around who do, and for them, this is, that's another issue. I mean, but certainly, I think the one major issue that I can't see the assistive technology getting around is the transition from autopilot between the vehicle driving and the driver driving. Typically, that will need to be done very quickly, and there is just, the developers are talking about, we give warnings. Well, when the chips are really down, the driver's going to have to take over, and you just cannot ask them to be taking over, be fully in the loop. It won't happen. Humans don't work like that. And anyway, I don't want to have a car where I just have to sit there and wait passively. That would be torture for me. And I think many people. I mean, I don't want to do it because I'd rather do other things, and I get enticed by the other things. And that is so likely. We know that's what will happen. I think this is where the problem lies. if you can give me assistive technology that helps me brake faster when there's a there's a danger, or puts me back on the road in a way that doesn't scare me and doesn't surprise me or confuse me if I'm heading off to a single vehicle crash and about to hit the tree, those sort of things, yes, if they're designed well and they work the way the person actually, as in aviation, they need to be intuitive and work with the way that humans work, which is why we want to understand how humans actually drive. So I think the answer is yes, full automation is definitely where I think we need to be heading. And if you're going to play in the partial automation stage, that autopilot technology is seriously a problem.
One other question right here.
Just wondering about some of the good measures of usability. And whether maybe there is a role of emotions in measuring, focusing more on these measures of emotions as a way of measuring usability. What do you think?
Look, I think usability is really about whether or not people can produce reliable, error-free performance. Because when you're driving, that's what we expect to be able to do. Certainly, and that's basic. That's what you do. I think there's real call, however, and opportunity to look at emotional change. And I mean, certainly, I'm very interested in fatigue in driving, and I've done a lot of research in that area. And certainly, there's an opportunity there to try and understand a bit more about that sinking into low alertness and emotional and physiological changes of that nature is certainly one of the paths we could be looking at. But yes, I'd suggest there's certainly a possible avenues we could do that. Yep.
I have a question here. Hi, thanks for the talk.
What does the research suggest is the most important gaps or opportunities for further investment in level 1 or 2 automation?
Look, it depends. The research or me? Certainly, if you go to say enhanced safety in vehicle conferences, where there's an awful lot of people, and the automated vehicle conferences, and I sort of regularly go to both of those, there's a lot of discussion about better sensors, because this is all sensor technology and there's a huge amount of research of all sorts. There's also a very large amount of research looking at how you analyse the data that comes in, because this is big. The onboard computers in vehicles now are getting more and more sophisticated. How you could use, say, the emotional change that you might experience through I don't know, some galvanic skin response and the driver holding the steering wheel, if they're still doing that, and judging the driver's state. Certainly there's a huge opportunity there for more sophisticated data analysis and so forth. And I went to one conference in Stuttgart a year or so ago, and they had a huge showroom full of hundreds of new companies, startups, that are doing exactly this sort of stuff. From my point of view, I think that we need to be trying to start asking the questions about that I've posed. What should we automate? What does a driver need? And how we do it best. Certainly, replacement of auditory warnings is one of the areas. There's a bit of research, but we definitely need to be looking at how you communicate information to drivers.
Thanks for the talk. I was just going to say, in terms of your opinion on it, do you think that's best to legislatively write that there should be no automation until we can get this sorted, or even have full automation? Or do you think that we should be allowing the market to decide and kind of putting the research out there, maybe giving the government warnings saying,
yep,
you need to have a look at this, and it's not always best to have beeping sensors everywhere? What's your opinion on that?
Look, I think I was trying to say at the end that the ANCAP kind of approach which has got demonstrated effectiveness, I think is one way that we could do it. And certainly we're talking to the ANCAP people about doing that. That way government doesn't have to legislate. In fact, government is very slow about, doing this sort of thing. And there's a question of what their role really would be. I mean, however, from a road safety point of view, there are a lot of things that are currently going in vehicles that are really not very safe. And so, we have double standards here. We worry about what kind of tyres you have on vehicles. Why wouldn't you worry about what kind of other technologies that, that might well distract drivers? I mean, the best example is the video screen that we now have in most new vehicles. I mean, there was once, the older vehicles where you could actually, by touch, you could change the radio station just because you just pressed a button. You knew the third one from the left was what you did. So that many of the common things you do in vehicles now require you actually take your eyes off the road and actually look. And quite often, touch screens, you can, if you don't do it correctly, you actually have to redo it and so forth. So the tendency to get drivers' attention away from the driving task through these technologies is very high. And I think this is something that does need some serious evaluation, and I do think that we should be being a bit more demanding of what we're allowing in terms of vehicles into Australia. We in Australia have a big problem because we have no influence now directly on vehicle manufacturing, because we don't have any as of last week. But we still have, in Australia, we have been very influential in lots of areas, and this is one area where we could actually lead the world, because these discussions are being had in other areas. I mean, certainly in the US, the NHTSA and some of the other organisations are putting out discussion papers and so forth, but there's not much actually really happening. Yet, I drove a Volvo XC90, I think, that is now currently our New South Wales authorities are considering allowing on the road. I wouldn't. It did things. I was driving along at 80 in the M5 tunnel, and the M5 tunnel has a nice little curve, and the technology didn't like it. So it turned itself off without giving me much information about the fact that it was turned off. I had someone with me, and I was actually, really driving, but it wasn't good enough. And I don't think that should be allowed on the road.
Final question, please.
So following up on the legal aspect,
yes,
as the driver loses control,
yep,
technology takes over. And
who's in charge?
Not necessarily who's in charge, who's accountable when there's an accident.
Sure.
And if it's the CEO, say, or Google, then that might focus their minds if they're going to end up in jail.
Yeah.
So what's your opinion on liability when it comes to levels 3 and 4?
Well, look, if the vehicle is in charge and the driver is just sitting there and it's the vehicle. Mind you, I was in a meeting, it was a year or so ago, where the person who's in charge of heavy vehicles for Volvo was basically answering a whole lot of questions like this, and he said Volvo will never be responsible. It will always be the driver. Now, I think he's wrong, and I think, that's probably not going to, they'll learn that the hard way. But yeah. This is something we really do have to work out, and it's not going to be a small issue either. Yeah.
Well, please join me in thanking Anne again.